so we're on homework 5.5 now. On the back, when we're looking at solving a system by graphing, or not a system, but an equation. So the interesting thing here is I have 3 to the 2x plus 1 equal to 27. And here's the cool thing about how we can use Desmos to help us out. So I'm going to switch over, not webcam, sorry about that, guys. So if I have Desmos here, I can type in 3 to the 2x plus 1, but it has to know like what I'm trying to say. So I just go ahead and say, okay, y equals 3 to the 2x plus 1. So 3 raised to the 2x plus 1. So here's the line of that graph. What it's asking is, when does that graph equal 27? So again, I can't just type in 27, so I say y equals 27. And now I'm going to have a line at 27. So what they want to know is, what is the x value when those meet? So all I have to do is figure out, well, when do those lines meet? There's my x value. Okay. Now the other thing that we can do, if it wasn't a solve by graphing, is think about these both having a base of 3. So and this is where like really oh, first off, this goofed up. So that's why it's probably getting such a messy number. That plus 1, why won't it let me do that? Oh, parentheses probably. Bet you it wants. Desmos is very picky with how you format. Aha! So now when I look for that intersection point, it's a whole lot easier. X is 1. But the other way that we could look at this, if it wasn't a solve by graphing, is to say, what would the power of this be if it's 3 to the something? Because it has to be equal to 3 to the 2x plus 1. So I need both bases to be the same before I can evaluate them. What power of 3 gets us to 27? So 3 squared is, then multiply by 3 again. There we go. So it would be 3 cubed. So what that tells me is 2x plus 1, that power, would have to be equal to that power. Well, 2x plus 1, what would x be? X would have to be 1. So that verifies what I found through my graph. X has to be 1. Okay. That makes sense?